Welcome, folks. We're going to be working on some of the coding work in Unit 1. This is not a lecture video, by the way. This is just get to the code. And we're going to start first with some of the you do it exercises. And then I'm not sure if I'll record some of the exercises into the same video or do a separate video. We'll kind of see as we go. We are working on Unit 1. We're working off of the Joyce Farrell Java programming book, 9th edition. Which I have pulled up electronically on my screen. But most notably, what we're going to work on here in Unit 1 is we're going to start with the you do it exercises. So as you're reading through that first chapter, you get to about page 20, I think it is in the hard copy of the book, I'm being told. On my Cengage ebook, it says page 21. But we're looking for basically the first you do it exercise in the book. Now, they do recommend some coding tools, and I'm just going to tell you right now, I don't necessarily agree with their choice. And I know that some instructors still like to teach with some of these older tools, but I've moved pretty strongly away from it. I like to start people with a real coding tool, and that's why we're using Eclipse. And you are free to use other tools, right? So if you want to follow the book approach, you can. But I'm going to skip the process where we're compiling from the command line and running from the command line. Not that it's not useful, but I'm going to be real frank. There's no professional programmer that dives in to learn how to code and goes right to that approach, because you know what? That's why a lot of people get scared away from code. I'll be real frank, right? It's like, oh man, command line, what the heck is a command line? You know, it's like this whole thing. The thing that you should know about that approach, though, is that you can write code completely from the command line. You can launch a text editor, type your code in, save it somewhere in your file system, manually go to that through the command prompt, compile the code, and then execute the code with some very simple Java commands. And they'll run in the command prompt just the same way they run in the IDE. Ultimately, though, it really isn't how professional programmers would prefer to work. So my thinking is, why are we wasting time giving you something really difficult to start with when that's not necessary? Okay, so I'm just putting it out there when you're looking at it. If you look at some of my older videos, like I'll call them my archive videos that are kind of like pre-pandemic and beyond, I do show that technique. So if you're really gung-ho, go for it. Watch those videos. We do a little bit in chapter 1, and then we never go back to it again, basically. You only do it in an emergency is really kind of the truth of it. So when we do these you do it's, and I want to be really clear here, they give you all the code and all the instructions for making this work. The biggest challenge is really taking that code and putting it into whatever IDE you're working with. We are working with Eclipse. Right now, if you've watched the previous videos where we saw how to install, make sure that everything's running, I'm just going to very quickly say that first you have to install the JRE version 8, the JDK version 8, and then preferably the portable version of Eclipse that I've given you to basically unzip and run. And just a reminder, the reason I do that is to reinforce that we will use that same exact software setup for Java programming too, so you don't have to get new software for that class. Also, Eclipse happens to be the most popular IDE for programming Java. And, you know, it really is a better way to learn, you know, frankly, because it's a proper IDE, as we call it. Now, in this first you do it, they're having us start the text editor and open a new document. So that's what we're going to do. All right. So I'm going to go and open up my IDE, which is Eclipse. And you can see I'm launching it. I'm running the Neon version. The version is actually not as relevant, frankly, as the JDK and the JRE underneath. If you guys are wondering why version 8, those are the enterprise versions. They give us higher level functions than the consumer versions, which are numbered much higher. And it's more like you can't connect to databases or create websites and stuff with those libraries. You have to use the version 8s. All right. So once you get into Eclipse, and we did a little bit of this last time during the install, but you want to attach yourself to a workspace. So in other words, a spot where you're going to store your code on your machine. The one word of caution I have is Whether or not this works well with automatic syncing cloud drives like OneDrive, for example, the jury's still kind of out on that. OneDrive has been kind of buggy for me with most coding engines. It seems to be okay with Google Drive. It also seems to be okay with Dropbox. And I'm not trying to promote those products. I'm just telling you my experience. If you want to be extra safe, really the best thing to do is to store on your local hard drive in a spot that doesn't sync to the cloud. You can always push it to the cloud later. All right. So choose your folder, and I would recommend that you put it in a spot that makes sense relative to the course that you're taking. Like right now, I'm on my G drive, but I want you guys to notice that this is my Java Programming 2 folder for 2024 spring. Really what I want is my Java Programming 1 folder for 2024 spring. So I'm going to browse and get to that spot. So I'm going to collapse Java 2. And in my drive, I'm going to locate Java Programming 1, which is the 184 class. And then inside there, I'm going to create a folder, and I'm going to use the Make New Folder button, where I'm going to create one called Spring. And actually, I like to put the year first because it sorts better. 2024 Spring, right? And then I'm just going to say, press Enter to lock that in. It is selected, right? I'm making sure it's selected, and then I'm going to say OK. So now you see Java Programming 1, 2024 Spring. If you know you're going to keep all your work in this spot, go ahead and click this little box here. You don't have to get asked again. However, it is important to note that if you have a bunch of workspaces that you're working with, and I do, this allows you to switch between them. You can always reset this from within the product if you check that box, by the way. I'm going to go ahead and say OK. Eclipse will finish launching. It will load all its little libraries and whatnot. Its interface, we'll let it load up here. I'm going to say OK to this screen here, and you don't have to say OK to that, by the way. And then I'm going to cancel the welcome screen and go full screen. Right now, we're still on step 1 in that you do it, which is to create a new file. But the way that Eclipse works is Eclipse wants you to create a new Java project first. Now, because of the way that I'm giving you these assignments, I'm just going to go back to the browser here. This is 2 separate sets of assignments, and each one of them has multiple exercises. What I recommend is that each one of those is a separate Java project. So if I'm doing this first, chapter 1, you do it, that would be a great name for the project, by the way. So I'm going to come up here to the file menu, or you can use this first icon here, go to new, and then create a new Java project. And then I'm going to entitle this, you can call it whatever you want. Spaces are fine in here if you want. This is just a folder stub, basically. I'm going to call it chapter 1, you do it. Okay. I don't really have any other selections to make here. I'm just going to go ahead and click finish. And then it will build the project and folder structure over here in my sidebar, which you guys can see now. And if you expand a little triangle here, you'll see inside here the system libraries. We talked about this real briefly. These are all the libraries that are bundled with this distribution at the ready, so you can include that code into your programs. And then we have the source folder, which at least at the moment is empty. I am going to come in here and I am going to create a new Java class. Now, I have one little complaint about the book, and I'm going to explain what it is before I take my next step. When I'm working in Eclipse, Eclipse wants me to name my files and my projects right when I create them. And that's really the better practice, by the way. If you follow the instructors or let's say the authors format, what they do is they have you type in all this code, and then at the very end, you hit save and give it a file name. And so this is just my tip. Go all the way to the bottom of wherever you do it, find the file name so you can include it correctly. And you can see here that they want us to call it hello.java with a capital H. So back over in Eclipse. I'm going to right click that source folder, select new class. Now all individual Java programs are a class, by the way. We are going to name it hello with a capital H. That's a convention in Java. It's not a rule, mind you, but the convention is that every class file starts with a capital letter, right? And the other thing that you might want to check here is this public static void main, because it will auto create this code for you, which allows your program to run. And I recommend that you do that. One of the reasons I recommend it, and I used to not, by the way, is because then you don't have to worry about making a mistake typing this in. Because if you don't get this exactly right, your program will just not work, period. Doesn't matter how hard you try. And on top of it all, it might not necessarily indicate that it's incorrect. So that's kind of a secondary feature. Another box I do want to draw your attention to up here is this package declaration. Now, for whatever reason, depending on what steps you follow to create your program, sometimes this is populated with information and sometimes it's not. My general recommendation for this class is that this is blank, right? Because we usually only use a package declaration when we're writing a bunch of little programs and running them together to make one big program, right? This is not what we're doing here. If we write a bunch of little programs, they're all separate little programs. They don't need to be part of the package. If the package declaration exists, you can leave it there. No harm done. It'll still work. But my preference would be that you catch it on the front end and just not have it. So just blank is fine. We just go with the default. I'm going to go ahead and click finish here. And then what this does is it builds the file over here in the package explorer. And then inside the coding window in the center, and I'm using Control Plus here, by the way, holding down the Control key and then using the plus key along the top row of my keyboard to zoom in on the code so you guys can see this. Otherwise, it is a little difficult to read. I want you to notice, and the people here in the session, because we were working on getting the software to work, we all have seen this step before, but basically we create a class file that holds the whole program. The name of the class is hello. Notice the capital H, right? Same as the file name. And this is a little thing I demonstrated before, but if that H is lowercase, then we got a problem. We start to see these red underlines here, and it indicates that this is basically incorrect. And of course, you can hover over any of the mistakes in Eclipse, and this is one of the reasons why we use it. It tells you what the mistake is, and then sometimes it actually gives you a fix, and you can click the link and it'll do a fix. Now, we know what we broke, so I'm just going to use Control Z on the keyboard to get back to where I was, so it's correct. Now, you'll also notice that we have at the beginning of the class statement this other keyword here, and technically what we call this is an access modifier. Not really super important. I'm not going to test you on that. But what it does basically say, as the word implies, it's public, meaning that from anywhere in the folder where this is stored, other programs can call this program and run it. And everything inside of it is accessible to things outside this program. So that might be what you want, might not be what you want. Often when you're getting programs to work together, that's required. So very, very common to see public class hello. Some people will replace it with private. There's other keywords you can use, or they just don't even include it, right? And they just say class hello. That's fine too, by the way, but this is more common. Inside the code, and how do we know it's inside the code? Well, we start to use what we call semicolons that encapsulate our code. And I'm going to, not semicolons, I apologize, curly brackets. And those curly brackets are located to the right of the letter P on your keyboard, just in case if you're looking for them. I do get people that sometimes can't find them, by the way. And they're the shift of the square bracket key. All blocks of code in Java, and truly in any C style language based on the original C programming language, curly brackets, this would be called an opening curly bracket where the little point is pointing to the left. This would be called a closing curly bracket where it's pointing to the right. but all our code in a class statement has to be encapsulated inside those curly brackets. If I am missing one of them, once again, Eclipse will start marking things red and telling us there's a problem. I'm Control-Zing out of my way out of that, by the way. Inside the class, we have another block of code, and this is what we call a named block of code. The name for this block of code is main. And when we write this, it's really in the form of what we call a function, and we'll learn about how to create those later. But for right now, we just use them, right? We just utilize them. And this is called, technically another name for it is the main method, right? So what the main method does is this is the block of code. So anything that goes inside these curly brackets will execute when I run the program. So if I don't put an instruction inside of here, it won't do anything at all, right? It just won't run. It's kind of like putting the keys in the car and not turning them, right? It's not going to run until you turn the key, right? And that's kind of what the main method does. Now, there's some words that you have to put in front of it to make it work correctly. So, and you can imagine that, like if you were learning how to do this manually, you'd have to memorize this, right? Absolutely exactly like this. All lowercase, public, static, void, main, a set of parentheses, string with a capital S, followed by a set of square brackets that are empty, a space, args, which stands for arguments. We'll talk about that later. Then you close your parentheses, open and close your curly brackets, and then your executing program code goes here. All right. Now you're looking at this and you probably go, well, I see a / to do auto-generated method stub. What's this all about? Right. And what this is what we call non-executing code. This is technically a comment, right? And if you want, like you could type it in and say, this is a comment. It will not run. It's just info, right? And that's what we use comments for. So look at how that functions. So this is not really a primary part of what we're doing now, but we have a separate udo where we talk about this more. But one way to do a comment in a Java program is to begin with 2 /, which is on the same key as the question mark, if you're wondering. And then anything that follows it will not operate as program code. It's just information, right? Professional coders use comments to leave notes for themselves, provide information for those that might look at it later, or just type silly things, or use it just to make things look nicer in some cases. All right, but this is a comment. Now we're going to actually write some code. And if we go back to the you do it now, we're ready to kind of do what they say. So the first thing that they say is to put in public class hello. Well, hello, we did that automatically with Eclipse, right? Eclipse did that work for us. Then they tell you like, okay, press enter, put in curly brackets. The one thing I do want to point out here that I think is kind of interesting, and I'll have you kind of look at how the anatomy of this is. I'm going to bump up our font size here just a little bit so you guys can see that a little bit better. But you'll notice like the curly brackets in my code, what Eclipse did is it put one right after hello and one down here. And the same thing with the main method. Then you look at the book, and this author uses what I call Microsoft style curly brackets, where that first curly bracket isn't put here, it's put on the next line. Either one is okay, doesn't really matter. This is just kind of me talking out loud here, but to me, doing it like this wastes one line of code. It wastes space I could use for something else. And so I like the approach that I use better. You can do it either way, doesn't matter. Most of your better IDEs will automatically do it the way that I did. So apparently the people that create them have this opinion. The next thing that they have you do is go ahead and create the main method. Now we, once again, did that automatically by checking that little box when we created the file. And so it's automatically created. And the only task that's left for us really is to get that system out print line, which actually puts something on the screen. So let's go back to Eclipse and type that in. All right, so here it comes. system with a capital S dot out dot print ln, or technically we call this print line. You notice as I'm typing, the IntelliSense inside of Eclipse kind of kicks in along the way, right? Now, depending on your computer, and I'm just going to kind of say this as well for your information, IntelliSense works better on a machine that has more RAM and more processing power and is not running a bunch of extraneous junk in the background, like 50 million browser tabs, for example, or videos or whatever, because it runs active in memory. So what this is really doing is it reaches into the Java system libraries that we saw in the sidebar, and there are descriptions of all the different methods and functions in those libraries. And as I'm typing them, it like auto narrows down, kind of filters down to the right thing. And you'll see, like, for example, with Printline, there's more than one version. We want just the plain one, which just has the two parentheses after it. So the top one is fine. So I can, at that point, just press enter and it drops it in. Notice how it did it automatically. It put in the parentheses, and real importantly, at the very end of the line, a semicolon. So here's some news for Python people, right? For those of you that have had Python, and I know you guys, some of you have. In Python, when you do a statement, you just type the statement on one line, and then when you move to the next line, it's a new statement. Not true with Java. With Java, the only way a statement ends is with a semicolon. So I type the command system.out.println parentheses semicolon. If you omit the semicolon, often your code will not compile. There's some exceptions. For example, if it's the last command inside a set of curly brackets, it won't necessarily throw an error. Here it is, right? And notice as I hover over it, it pops up a little box that says syntax error, insert semicolon to complete block statements, right? And you can actually, in some cases, have it do that action, but that's an easy one to type in, right? So you got to get in this habit with Java. Whenever you make a statement, semicolon's got to be at the end, right? All right, so let's get something on the screen. Let's put a set of double quotes inside of here. And you will notice that I typed one double quote, Eclipse closed it automatically for me, a second double quote. I want you to notice also really carefully that these double quotes are straight up and down. And that's different than the kind of double quotes you get in Microsoft Word where they curl one way and curl a different way. So be really careful if you ever are copying code from somewhere, that you can copy curly double quotes into coding and it doesn't work. All right, but straight up and down ones do. And then you can just, in between those double quotes, type your message. Now, the most typical thing to do for your first program in a new language is to write hello world, just to prove that you can get something up on screen. Once you have that typed in, go ahead and save your file. And in Eclipse here, and this is hard to see on my screen because my resolution is pretty high, but right up here on the tab, there's a little asterisk in front of the file, which indicates to me it is not saved. So I can come here to the toolbar and either hit the save icon or go to File, Save. I'm just going to hit the save icon. You can see it's saved. Now, I changed my mind. I want to add 2 exclamation points now. Right? And once again, it's unsaved. I just want to give you this tip. When I hit the run button, which is what we do to get our programs to execute, it will automatically ask you to save if you haven't. So I'm just going to demonstrate that. Here's the run. And there's the box. And it says save and launch. And you say, okay, right? So I'm going to say, okay. And now it's going to run. And what happens inside of Eclipse is once you run a code file, that's a console program, and that's what we're writing here is a command line or command prompt or console program. It will output at the bottom in a tab called console. And what really is happening down here, and I want you to conceptualize this, Python people will kind of have the vibe for this already because in Python, we had a command prompt also, and your programs would output to it. But what's happening inside this window, the Java runtime environment, or the JRE, or the JVM, virtual machine, is operating inside that window, and we're propagating a program into that environment. The convenience here is basically, compared to what the book is showing us, I don't have to go to the command prompt to compile, hopefully not get any errors, right? And then back to the command prompt to run it, only to see this message from a command prompt. Now I can do those tasks. You can follow what Appendix A in Chapter 1 says if you really want to learn how to do that, or you can watch my old videos, but my thinking is why, you know. This works just as well. You can see your output right here, right? All right, so this is the console. This is our coding window. This is our package explorer, our Java file, which is a class file, our project called Chapter 1 You Do It, and that was the first You Do It exercise in its completed form. Now, you know, we completed all the steps. And then we'll move on. And so what I'm going to do in the book here is I'm going to try to hit basically all the you do it. So I'm going to hit at least the first couple, 2, 3. I don't know if we'll do all of them. But what you'll notice here is as you're doing these is that you will find their complete step-by-step instructions are provided almost too much. And so they show you the code that you should type in, what it looks like, and what it should do, you know, when you run it. So now they're kind of looking at some stuff here, and what they're trying to do is get us to trigger an error to happen, and that's what they're showing in this first screen here. So now we're going to do the same thing. We're going to take our file that we just created, hello Java, and we're going to break the code, okay? And we're going to put in some code and see what happens with errors. So here's how I'm going to handle this. I'm going to go back to Eclipse, and I'm noticing right away that they want us to call this hello errors. Okay, so we're going to create a new file. We're going to go back to Eclipse. I'm going to come up here, and you can do this a number of different ways. I can either do it on the root of the project or on the source folder, and you can right-click, select New from the pop-up menu, and then choose Class. Right? They want us to call this hello errors. And remember, I gave you the tip that I went to the end to see what the name was, so I didn't have to do all the steps and save it later. I also know for sure you need a public static void main. Why? Because our programs won't operate without it, right? Period. So you may as well just click that box. The package declaration is blank, which is what I prefer for programs like this, and I'm going to click Finish. Now you'll notice it creates another new file, so that ends up in the source folder here. And notice the name, hello errors. It's all kind of set to go. Now what they're telling us to do, I'm going to get rid of the comments here, by the way, is to do the hello statement and then add another one that this is a test. And then what they're going to have us do is they're going to have us break things and put things in incorrectly, and then we'll go in and try to fix them. Okay, so I'm going to try to follow sort of what they're doing, but it might not be exactly the same. And you know what? It doesn't have to be the exact same error. The whole point is to trigger an error so when it happens to you on your own, you don't freak out. Okay, so newsflash, right? Like when you're writing code, most of the times you're writing code, you have errors. And it's when you fix the code, you go, woohoo, I did it, you know, and that's when it works. So you don't get frustrated when you have an error. That's just part of the process. Okay, so let's do 2 system print line statements, just like they have here. And it's okay, by the way, if you go to your previous program and you can copy it, you don't have to retype it, right? So I'm going to take the first one and I'm just going to retype it, or excuse me, paste it. So, and you know what? They just said hello, so I'll just say hello. Then I'm going to do another one of these. This time I'm going to type it manually because once again, I want to kind of show you the IntelliSense on here. So capital S, Y, S, T, E, M. It doesn't really quite know that it's a library yet until I hit that button. So I hit a dot, Now it says, oh, you want the system library. Okay. And then we want to do output. So we call out, which is a library within the library. And then we do dot, and we know we want to do print line again. So let's do print ln. And then this time, instead of double quotes here, we can say, something else. It doesn't really matter what it is, right? Now, I'm intentionally leaving the semicolon off. So that's the first error I'm going to make on purpose, right? And they kind of do that. So I'm going to go ahead and hit run on this. And we already know it's not going to work. Okay, so whenever you're in Eclipse and you see a red mark in the sidebar here or here, or in the code as an underline, and I'll just zoom in just ever so slightly so you can see it even better. See that little red underline? It knows there's a problem, and it says, insert a semicolon to complete the statement. Okay. Generally speaking, this isn't going to run when it's got a red mark. So hit the run button, but we're going to go ahead and let it save and generate. And notice what it says. It says errors exist in required projects. Proceed with launch. Like, are you sure this isn't going to work? Right. Well, we're going to proceed. We know we're not going to get any output here, but what we are going to get is an error message down in the console. And I do have this really huge. I get that, right? Pretty easy to read, though, you got to admit. And what it does is it tells us where the error exists. So it says, exception in thread main, Java language error, unresolved compilation problem, syntax error, insert semicolon to complete statement. Where is the error? Okay, right? Because what if I have 1,000 lines of code? How do I know where the error is? Well, it tells you. It tells you the name of the file. Notice, hello errors.java, and then :6. Well, guess what that means? Line 6, right? And then it'll output like this. Now, I do want to show you one thing that's kind of interesting when you do it on a command line, and they show the output of it here. On a command line, I don't know if you guys can make this out. Like if you're missing a semicolon, it'll try to put in this little pointer that shows you where the exact problem is happening in the code. In Eclipse, it doesn't quite show it that way. But, okay, I can go to line 6, and notice how this is a link. I can click on it, and it takes me right to that line, right to the spot of the error, right? And so if you had a whole list of these, you would start fixing them, right? Okay, so we know how to fix this one, right? So here's an example. We'll fix it. We'll put the semicolon in. But what if I didn't name the main method right? What if I named it min, the min method, right? All right, let's run this one and see what happens, all right? It's going to ask me to save because I didn't save. And then it says error, main method not found. That's true because I changed the name. Please define a main method as like this. So it tells you how to write it. Like, you forgot how to write it. So check your thing. Or if you're doing a Java FX application, that's what we do in level 2, by the way. So that's the Java programming stuff. But actually, if I look at my code, technically, there are no errors. There's no red underlines. There's no yellow warning marks. And so I didn't type my code incorrectly. Well, I did, but technically the syntax is okay. It just won't execute. But it is recognizing there's no main method, so nothing will actually happen. So it's not necessarily bad to, you can have, in other words, you can have other methods or functions in your program with different names, and it's not considered wrong, right? It just won't run. The main method is an important one, and that's one where you have to kind of, either you memorize that or you use a good IDE. Now, there's all sorts of errors that you can make while you're doing this. So it can range from, like, for example, you forget a double quote. And it's kind of fun to kind of just make a couple of mistakes like this on purpose just to see what the error outputs are, right? If I hover over the mistake, it should give me something similar to what is listed below. String literal is not properly closed by a double quote. And notice it has one quick fix available. And you might be a little hesitant at first to use these, but I'm actually going to use this. So I click it, and it threw one in. Okay, well, that wasn't the fix it was hoping for, right? Because that's not where I took the double quote from. So just because a quick fix is available doesn't mean it's correct. No, it still takes an intelligent user to put it in the right spot. So I'm going to Control Z that and then type in the double quote where it needs to be, right there. All right. Now, this is basically how this exercise goes. It's just basically making errors and fixing them. And they kind of ask you to do a couple different things. So one thing is to remove the word void, right, which is required. And then notice it'll point that out. You can also like remove, semicolon or a closing bracket or something, and it'll point that out. And the real exercise here is you get errors, cause them on purpose just to see what the error messages are. So you can see, like, once you get an error message for real, okay, now I have to pay attention, but hey, I know how to fix that one, right? And you know what to look for. It does take practice, right? And once again, the IntelliSense tries to help you, but its suggestions for fixing aren't always correct. So, beware, just, watch it basically. All right, we're going to move on and we're going to try to hit, let's see if there's maybe one more in here we'll hit. I'm going to kind of play it by ear, but otherwise I think I might switch over to the regular exercises. All right, so they talk about running an application. I'm just looking for the next you do it here. All right, this is kind of an interesting thought, and I'm just going to kind of stop on this because this is a really important concept. When we create a new program, and I'm just going to do an example here. So I'm just going to, you can do this if you want, but you really don't have to. And I'm just going to call it silly example. Let's just call it that. That's pretty silly. But I'm going to go ahead and just create a silly little program here that doesn't really do anything. That's blank, right? And so often when programmers start an application, rather than write code for hours and hours and hours, and then after they think it's okay, then they hit the run button. It's not how programmers operate. More often what programmers do is what I'm about to do, is they build a program just to get it started, and then right away they run it, right? So the reason, here's the methodology for this. When you go ahead and you run it, it does in the background, it debugs the code, so it reads through the code to make sure there's no errors. If there are, it'll stop and suggest the fix. We just did that, right? If there are no errors, though, it will continue and it will compile the program and turn this into a binary executable on a Windows platform. Ultimately, it'll be an exe file. We call it a class file, but whatever. It's an executable file. And then on a Mac, it would be an app file, right? Either one is executable. So now we've already built what we call a clean version of this. Doesn't have anything in it, nothing fancy here, but we call that a clean build, meaning that we have a starting point, right? Often when you have an error in a program and you go to run it, sometimes the dialog will ask you, hey, this is a bunch of errors in it. Do you really want to proceed? Or do you want to use your last clean build? So when you hear that clean build, that's what it's referring to. And if you say okay to that, it's not going to run the version you just made. It's going to run the last one that worked, right? Sometimes that's what you want. Sometimes it isn't, though. So you got to be mindful of that. This is my silly example of a clean build. And so if you want to put that in the comments here, silly example of a clean build. And, it does nothing at all. Whatever, doesn't matter. So that was the silly example. Let's go ahead and save that. Let's take a look at, let's see where this next thing happens. So like the first errors that we manually created, and I'll have you start thinking about this, when we were working with this, we wrote correct code, bad spelling here, but we wrote correct code, and then we intentionally broke it to see what the error messages are. Now, The type of errors that we were fixing were what we call syntax errors. They're language errors. I didn't have a semicolon. I forgot a double quote. I didn't spell something correctly. That's syntax errors. So they're in how we typed it in. But sometimes you create programs that have what we call a runtime error, meaning the program compiles and runs, but what it's doing is wrong, meaning the logic that you use to create the code is incorrect. In this example, what's the logic error here? You're trying to say first Java application and you spelled Java wrong, like I spelled else wrong, right? So we call that a runtime error. It runs, it's just not right. So it's a runtime error or a logic error. When you build more complicated programs, by the way, and you have logic errors, your sequence of steps might be in the wrong order, your math might not be right, or you're not saving something correctly, etc. And that comes with a little practice to get it right, right? It is frustrating, like if this is your very first real programming language, it can be frustrating when you have errors because you don't know what to do. You will discover, and I don't know if all of you have taken Python, but those of you that have taken Python already, that a lot of the stuff we do here will feel a lot easier because you've had that experience of running code, fixing code that's broken, and seeing it when it's broken, right? And you're more comfortable with that process. So that takes a little getting used to. Please don't let mistakes in your code scare you away. That's normal, completely normal, and more common to make mistakes than not in programming. Right, trying to get to the next you do it here. Let's see if it loads up. It's slow as pie. Right, so the next little example is talking about comments, and there's basically two major ways to do comments in a program. The one I've already showed you, so let's go back and just take a look at that. And so if I have a piece of code, and let's use the silly example here, right? This would be called a line comment. And the reason we call it a line comment is you do those 2 forward slashes at the beginning of a line, and anything that follows is ignored by the Java engine, right? If I was to take that line comment and put it here, it would make that not function. Now it is breaking my code because there is a curly bracket that goes with it. So if I want to really be correct with it, I would line comment that. Now, if you have a bunch of lines of code to line comment, by the way, it's not always best to do it that way, because then you have to go to each line, do a / at the beginning, to try to fix things. I will make one little note that I think is kind of interesting here. Like if I look at like this program, I've been doing the example where I do the line comment like this at the beginning and the whole thing stops functioning. However, if you put a line comment at the end of a line, I can, put notes here, right? The code still executes, but everything after the 2 slashes doesn't. So I can put comments along the way, and this is kind of like in the sidebar, right? But anything after those 2 slashes won't work, by the way. Now, if you want a way to be able to comment out an entire block of code or multiple lines of code, as web developers, and a lot of you guys are web developers, you can use maybe a more efficient approach, which is to get multiple lines of code, is you use what we call CSS style commenting, where you start with a / and an asterisk, which is the shift of the number 8 key, and then terminate with a asterisk and then a slash. And everything in between then becomes a comment. So now the main method here in my program is irrelevant. It's not going to execute, right? The nice thing about working with these is I can pick these up and move them, comment out more or less code than I might want to, right? And if you're doing multiple lines, this is kind of easier than doing the forward slashes. You can use either one. Either one is valid. It's fine, right? It's just good to know that both of them are out there. The other thing that we want to kind of look at is this thing called Java docs. And this is kind of really an interesting little thing to do. All right, so I'm going to get rid of these comment marks. All right, and it should be back to normal here. And what I'd like to do is introduce you to what Java docs are. And basically, because we have this IntelliSense thing that features, that automatically kind of helps us with our code. We also are tied into all the Java documentation that travels with the language too. So part of these libraries here is a complete listing of documentation for the language for all the functions that we're using. And I don't know if you guys caught this, but when I was hovering over print line, it's like, oh, wow, okay, what's this? Okay, well, where's this coming from? Well, this is coming from the Java documentation, the internal documentation for the product. And notice it says void java.io print stream print line string x, whatever the heck that means, right? And then it's showing you how to use print line in the box. And it says print line, public void print line string x, prints a string, and then terminate the line. This method behaves as though it invokes print string and then print line, whatever that's supposed to be. But I'll have you notice that down in the bottom right corner of that yellow box, there's also, it says press F2 for focus. Okay, let's press F2. Now, be mindful of this. When you press F2, a lot of us have flipped keyboards. So for me, if I actually press F2, it's like turning my volume down. So I have to hit my function key and then F2. And then notice how I converted it into a window with scroll bars and stuff, which you can then expand if you want to read more. There's not really much more to read here. Or at the very bottom here, there's a couple of different options. And notice show Java doc view, which is this tab down here. So you can look at the Java documentation in the tab, or you can open a declaration, not what we want to tinker with right now, or more importantly, and the one I think is probably the most helpful, is you can open the attached Java doc in a browser. And so what it does, and so here's another reason to use Eclipse. Eclipse has a built-in web browser, right? So this is actually going out to both the internal documentation, and if it doesn't exist internally in our libraries, it then goes out to the Oracle website and pulls down the definition for that print line function and tells you all of the different ways that you can use it, all the painful details of how print line works. This is actually a pretty simple one to use, but you do have sometimes ones that are really complicated and have multiple sub-libraries and stuff. But here's the beauty of it. You don't have to go to the internet to search for how it works. You can do it right inside Eclipse, right? So this is one of the reasons. Now, this is one of the UDoits also where they have you like look up a couple of things in Java docs. And here's what I'm going to do, folks, is this UDoit video is going to end here. You'll be on your own to complete the rest of the UDoits, right? You can watch my older videos if you really, really, truly need the guidance or reach out to me. But they're pretty self-explanatory, and we've kind of functionally done them all for the most part already. But just make sure to complete all of them. So we're looking for all those UDoits. All right. So I'm going to go ahead and basically, at this point, consider this. Let's say the UDoits are done. So I'm like, hey, I'm done with my homework. Woohoo! Right now, we got to turn it in. Okay. How on earth am I going to turn this stuff in? So here's how I want you to operate. I am going to have you submit your code. So that's going to be a standard thing you're going to learn how to do. But I'm also going to teach you guys that for me as a coding instructor, and I want to know that you wrote the code and that it worked, and I want to see it working. And for that, you're going to give me screenshots. Python people, you guys know the routine, right? I'm going to ask you for screenshots of your code and a separate screenshot of your program running, placed into a Word document or Google Doc, whatever, with a little bit of annotation, in other words, words that describe what I'm seeing so I know what I'm looking at. And then you would submit that document and a zipped version of your code. So I'm going to do all of those processes right now to demonstrate. When we do the chapter 1 exercises, I'm going to do the exact same thing. Right, so let's start with the UDoits. Okay, so with the UDoits, I have a few different code files here. So I'm going to first launch Microsoft Word. That's the tool I'm going to use is Word. Right. I happen to have an installed version. You might have a browser-based version. It doesn't matter. If you prefer to use Google Docs, feel free. No harm done. You can use whatever text, not text editor, but word processor that you want. If you're on a Mac, you can use Pages, for example. They do want me to sign into Office. I guess I got to do that. Oh, no. Okay, so this is making me do all these steps I don't want to do right now. So I might switch over to Google Docs if this becomes a pain. So I'm going to click next. Now it's probably going to ask me to authenticate, but that's okay. You can watch me fumble. It's great fun. Just to show you, I have to go through it too. And I am going to click remember me. And then I'm going to get my password in here. Continue. And I might have to do second factor authentication. But I'm going to use the one login protect method. And you guys don't usually use this approach, but I do. And here's my notification. So I just have to do a push notification on my phone here, which I just accepted. So I should be logging in. And then I'm going to say, remember me, so I don't have to sign in every darn time. And I'm not a fan of that, by the way. And I'm going to sign into this app only is what I'm going to do. That's the way I choose to do it. I don't want to sign into our campus network, basically. All right, so now I'm signed in. And I'm going to create a blank document. Here it is up on the screen. I'm going to go back to Eclipse. It might be good to start with a title. So I might want to say chapter 1, you do it exercises, right? And you know what, that's a title. I could highlight it and just come up here and click title, make it bigger. And then down here, I'll put the name of the first exercise, which was, I think, Hello Java, right? So I'll just say hello.java. And sometimes it'll be like exercise 5 or something like that, chapter 1, exercise 5, whatever. First, I'm going to do a screenshot of the code. So I'm going to go back to Eclipse, and here is my code, right? I'm going to launch my snipping tool. So in Windows, we use the snipping tool. On a Mac, you use the screenshot tool. And so in Windows, I would type snipping tool, bring up the tool, hit new, and then I'm going to select my code with line numbers like that. Notice I'm trying to be real tight on it. I don't want the whole window. I just want that code, right? And there it is. So I captured it. Now over in the snipping tool, I can just hit the copy button or Control C, either way. So there's copy. I'm going to back to Word, and I'm going to paste that screenshot in. And I think I did it. Let's see if it, oh, I didn't hit paste. There we go. So there it is, pasted in. Now notice, compared to my regular font size, the font inside of here is pretty readable. It's about the same size as the font in the document. So this will be no problem for me, your instructor, who's grading your work for a grade. So you want to make it readable for me. Then I also want to see it running. I don't want to just see the code, right? I want to see it executing. So what I want you to do then is go back to Eclipse and hit run. And then whatever your output is, right? I have to save it. You can capture that too. Now, I'm going to capture that as a separate screenshot. And I think typically this is the best approach. 2 separate screenshots. And then I'll come in here and paste it in again. So there it is, right? Really easy to read. That might even be too big, so you can make it a little smaller if you want. And then what I prefer is that, oh, this went great. It's a comment, this went great, no problems. Or, if it was a problem, then you might type help, all caps, bold, red, yellow underlines, whatever. Emojis, whatever it is to get my attention. I would hope that you would have reached out to me sooner, but I'd like to hear feedback. So if you're working on your own and you struggle, I'd like to hear about the struggle or the success, right? And then you'll go through and you'll do each exercise this way. Now, I guess you could argue that with a really simple program like this, I could have just moved this divider up, right, and captured all of the screenshots at once. I could have done that. And that's kind of okay as long as it's not too much on the screen. If it's getting to the point where you're pasting it in the document and it's like tiny and you can't read it, you can bet that I'm not going to be able to read it and probably not like it, you know? So keep that in mind. All right, so that's the document. So I'm going to take that document now, and I'm going to save that where I put my files for this class. So here's where I'm going to put mine. I'm going to go to my Google Drive, which is where I'm storing my stuff. I'm going to find my Java 1 folder, which is the 184 class. I have it in this, all my work's going to go into this 2024 Spring folder. The code goes here, but I don't want you to put your document there, right? Keep that outside of that folder and save it one level above. So I'm just going to save it right here on this spot. It's pretty self-explanatory because I titled it well. So I'm just going to say save, right? I'm going to go ahead and close Word because I'm kind of done with that process. And then I'll go over to Blackboard to turn this in. So I'll go to the Unit 1 folder. I'll click on the title of the assignment. That will tell me the due date. I want you to notice that's coming up pretty quick on the You Do It. This is for 2 points. And I'm going to basically upload my files. If you have something to say to me, you can type it here under Create Submission. If it's really, really short, you can put it in comments. But generally, I prefer Create Submission. I'm just putting it out there. If you have files to upload, which we do, you will attach them here. So the way that I prefer to do this is I pull my folder up on the screen while I can see that box. That's not the folder I want, by the way, but I'm going to go to the folder I want. I'm going to create a new tab here. All right. This is Windows 11, and we can do that. So I'm going to find those files. So this is why it helps to know where your stuff is, right? So you don't have to fumble looking for it. Go to that folder. There's my document. Document ideally should be posted first. Just drag and drop it in. And then if I go back to that folder, I'm like, oh, the instructions say that I need to zip my code, right? That's what my instructions say. So I'm going to go to this folder here, and I'm just very simply going to right click and then compress to a zip file. If you do not see this on the right click, you can also do it through the toolbars, or you might have to go to show more options to see compressed file. The Windows 10 way to do it, by the way, is like this, where you go to send to and then choose compressed zip folder, right? That's the Windows 10 way. And older, the modern Windows 11 way is just right click, compress to a zip. Right, so I'm going to do that. It'll create that zip file. Once the zip file is created, I'm just very simply going to drag and drop that over to that box. See how it turns purple, and let go. And you'll see my document and the zip file, and then you just hit submit, and your homework's off for grading, right? And this is very typically the typical way to turn in the homework is you write your code, screenshot the code, screenshot it running, zip your code folder, submit those two files separately, doc first, zip file second. And generally what happens on my end is I get that file, and I'll have you think about this for a second, right? Because if you're looking at a Word file that has program code in it, so I'm like reopening this. Did I actually save it? Yeah, I did. Okay, there it is. Right. And if there was a problem, by the way, with your code, it would be underlined red. So I would know you have errors just by looking at it here. That's another advantage of using Eclipse, right? And if you have problems and your code's not running, then I'm likely to go into your zip folder, unzip things, try to run it and see why, right? And then usually I'll ask you to fix it, by the way, so you can get your points. I don't want you to not get your points, but you have to know how to fix it, right? So that's part of the process. But that's the primary approach. This makes my grading a lot easier. What I usually sometimes have to remind people is don't zip the document into the zip folder, because then I have to unzip it to get to the document. And then I'm just like, whatever, I'm just going to run the code, right? Because often I can just grade right off the document really super fast. So I appreciate if you do that. If you come to these class sessions like you guys are doing, which I recommend, right? You show up every week, we'll code through every exercise during the section. I will do the whole semester. You get all the answers, right? And if you don't get them in the session, you will get them in the videos, right? So you will always have solutions available to you. But if you show up, you'll get all the stuff done and it will be correct. So that's the advantage of coming to class. If you're relying on the videos in the first unit, I'm just going to kind of put it out there. The exercise videos are present or were present from the moment I published the unit folder. If you go to unit 2, and I just published that a little earlier today, you will notice here in unit 2 that to start with, I have the lecture videos and a couple of the you do it's, and then also a little overview on Eclipse and stuff. But the homework videos are not here, and they won't be posted until just before the due date or after. Now, so if you're relying on the videos to do the work, you're going to run into trouble. Now, if you come to class, you'll be fine because we'll code through in class, and then the videos will be out there, whatever. I might even record videos during the class. But that's kind of the general pattern. I do want you, especially if you're an online person, to struggle a little bit with doing the code. That is part of the process, is to struggle a little bit. If that feels really uncomfortable for you, what I suggest, and I say this predominantly to online people watching this in video format, is come to the weekly sessions that you're invited to. And for spring semester 2024, that's Tuesday evening, 7:50 to 9:50. Zoom link is in the course shell. Just drop in. You don't need an appointment or anything. And you can come in whenever you want. If you signed up to be on Zoom, like I assume the people in the session here, you guys already know it's better. It's a better learning style for you, probably. Plus, you can ask questions, get answers right away. You don't have to wait days for responses. I think it's a better learning format. All right, now I was hoping that we could get to doing the chapter 1 exercises, but we're not. So the first thing I'm going to do, right, and I'm doing this in the video so you guys are aware, is I'm going to look at the due date. I know the you do it's are due in a couple of days. I just did most of them for you, so you guys should be okay. But let's see when the chapter 1 exercises are due, and you'll notice I did have them set for Thursday the 25th also. What I am going to do on those is I'm going to push those back so that they're due at our next class session, because I want you guys to have enough time to work through them. And what I'm going to recommend that you do is, because I'm probably, not going to record all of it, during the next session, because I do want to get on to the next chapter, is I'll basically tell you that you can come here to this video, has all the solutions for the chapter 1 programming exercises. This is recorded spring semester of 2022. When we come back next Tuesday, I'm not sure I'm going to have that kind of time. We spent a lot of time with software tonight, which is why we didn't get to exercises. But you can see with my guidance, it takes about 40 minutes to do those exercises. It's not super bad, right? So my suggestion would be try to do those exercises on your own as best you can. And if you struggle, go to the video. If you still are struggling, contact me, or we're going to do it in class. But normally we'll do most of that coding in class. So once you get done doing those exercises, start reading chapter 2, because we're going to dig into that next week. And I'm trying to think there's a couple other little tidbits I want to talk about here before we kind of adjourn for the day. So I'm going to show you, first of all, where do you find those chapter 1 programming exercises? And you have to have the book. Okay, so that's one of the things. So when you get the book, when we do the chapter exercises, it'll say something to the effect of complete chapter 1 exercises number 6 through 11, or I will list them individually. Okay, so let me take you to the book to show you where those are. At the end of each chapter, so you can see right now, I'm actually in chapter 1 and I have it really expanded pretty far. And notice at the end of the chapter, they have key terms, the chapter summary, review questions. That's not what we want, by the way. Those are review questions. We want the exercises. So I'm going to click directly on that entry here, and it's taking us to that part of the book. And I want you to take a look at these. Like, some of these are kind of like, question and answer, like multiple choice kind of things, right? And so that's why I'm not having you do exercises 1 through 6. When you do get to the first real exercise, which is exercise 6, this is all the instruction you get. So I'm just kind of showing you this so you guys know how to proceed. And that is, it says, write, compile, and test a class that displays the first few lines of the lyrics of your favorite song. Save the class as songlyrics.java, tells you what to save it. And as you work through the programming exercises, and okay, they give it a little tip, you might want to create a separate folder in which to store the files for each chapter. And that's basically the same tip that I just gave you. So if you're going to do exercises 6 through 11, which are all kind of in order here, they can all be part of that same Java project, just new files. So chapter 1 exercises or project should include song lyrics Java, movie quote info, table and chairs, triangle Java, comments Java, and comments dialogue Java. Right? It should include all of those things. The only thing that's going to be new to you is this comments dialogue thing. I'm not overly concerned about it. It's an old school GUI approach, but it does show you how to do really primitive GUI. We won't use that very much for this class, but a little flavor of it. So that's kind of the overview, folks, of how to proceed with this. Once again, if you want to work on that code, because I don't think I'm going to be able to fully video record it, you go up here to Unit 1 and use this set here. That's the most recent one. That's really good. It covers all those exercises. And all of them, by the way, are basically a repeat of what we've been doing tonight. It's creating a basic program, doing system out print line, and putting stuff on the screen. That's what that whole chapter is. The other tip I'll give you is, as we're working through the course, many of my units of instruction will also have extra credit opportunities, which are at the very end of the chapter after the exercises. There's case problems. And I will tell you, the ones for chapter 1 are super easy to do. I would strongly recommend that you try them because it's easy extra credit work, right? You can bank those points for later. The one thing I also tell you is, unlike my Python class, I'm not doing Kahoots in here. If I do, they're going to be super rare. So there's no like extra credit you can pick up from Kahoots. You know, we do more coding in here than we do that kind of thing. All right, I'm going to stop the video here. I know some of you might have a question or two, but we'll answer them after the video ends. If I can just find the stop record button here, there it is. So this video ends here.